All right, so we are about to begin the final session of the Current Directions in Psychological Science Speaker Series presented by Pearson APS. Our next and final speaker is Mark Krause, an associate professor of psychology at Southern Oregon University, where his focus is on teaching, writing, and supervising student research. Dr. Krause has conducted research and published on pointing and communication in chimpanzees, predatory behavior in snakes, the behavioral and brain basis of conditioned sexual behavior, and the influences of testosterone on cognition and brain function. Through his years of teaching, Dr. Krause has developed an interest in the topic of scientific literacy, particularly how the concept helps his own teaching, as well as how the science of psychology can contribute to the discussion and assessment of it. And so his talk today will focus on integrating perspectives on scientific literacy into the psychology classroom.
Okay, thank you, Nicole. And also wanted to thank Pearson and APS for the opportunity to give this talk. As Nicole said, I'm Mark Krause, and I teach at Southern Oregon University. And my background is in neuroscience and learning and memory. And I teach courses in those topics and also in general psychology. And within the last 4 years, I've really been thinking about this term and also the concept of scientific literacy. And also been very curious about how we might incorporate it into the psychology classroom and also implement the broader goal of kind of adding psychology to discussion and assessment of scientific literacy. So first of all, I want to establish a couple things. Why is scientific literacy important? Why should it be important to us? A scientific literate society is, for one, a productive one, and it's one that can actively contribute to individual and societal issues. And also it's one that is prepared to evaluate information and claims. And I think that becoming scientifically literate is the basis for a very well-rounded education. Obviously, literacy in arts, humanities, and other important endeavors have their own advantages that they can claim. But I think that the focus here obviously is on scientific literacy. And why this term? Why bother to use it in the context of teaching psychology? Actually, when I was in school, in college, I remember being scientifically literate seemed to mean being able to answer some true-false questions about scientific facts, and the term was really restricted to fields of biology, chemistry, and physics. And as a psychologist, I've come to believe that our discipline can contribute a lot to the discussion and the evaluation of scientific literacy. And actually, the media is a really nice place to start when it comes to discussion of scientific literacy. Most people get their information about what's going on in psychology from the media. That's not necessarily always a good thing. And I think this headline, if you just take it for what it is and don't read any further, kind of tells us why. You look at this and it's very easy to maybe trivialize, for one, what scientists do, and for two, what behavioral psychologists do. And the reality is a very interesting story that came out just about a month ago. Suzanne Higgs and her colleagues reported that people who drink in unfamiliar environments tend to be less inhibited, and the reason why has a psychological and an underlying physiological basis. And when you read the short article, you actually find that a basic understanding of classical conditioning and a little bit of understanding about what alcohol does and tolerance and addiction is sufficient to understand the gist of this very interesting work, and not just the gist of it, but it gives you enough ability to apply it too. And I think that evaluating student understanding of news articles is a great classroom strategy. I use it myself, but it's not necessarily practical for conducting broader assessment of public understanding of science. And public understanding of science and scientific literacy are very closely related. And before explaining why this is the case, we should try to maybe come up with a couple of definitions of scientific literacy so we can establish where we're at and have a common language. According to the National Science Education Standards, scientific literacy can be defined as the ability to ask and find and determine answers to questions from everyday experiences. It's the ability to read and understand articles about science in the popular press. Also being able to evaluate the quality of scientific information based on its source and methods used to generate it. And we're not necessarily really talking about super high-level abilities here. I think that these are goals that can be accomplished over the course of a 4-year undergraduate education. But it does take some time and some doing to get to these points. We can also think of scientific literacy as subdivided into a few different types. Practical scientific literacy, a cultural scientific literacy, and a civic scientific literacy. And this is according to Benjamin Shen, who divided these into scientific literacy into these 3 different types. The top one there, practical scientific literacy, that's the one that we tend to probably be most familiar with, because a lot of standard assessments of scientific literacy use a practical scientific literacy approach. And what I've done here on the slide, I've basically just taken a sample of questions that were asked by National Science Foundation and also collaborators in a large-scale survey of scientific literacy. And these are practical scientific literacy items because, as you can see, they're true-false statements about things like, in the first one, radioactivity, is it man-made or not, false. Electrons are smaller than atoms, true. The center of the Earth is hot, true. As you look through here, you see that you're basically just going through and identifying true-false statements, and then the results that NSF gets form the basis for how we kind of view scientific literacy in the United States, and also similar measures using practical approaches that have been used abroad to make comparisons across different nations and see how they stack up in scientific literacy. And as you can probably anticipate, if we look at results for surveys like this, I just have a sample of some of the results that have been found. 80% of the respondents, so the majority, knew that the center of the Earth is hot. And don't worry, we're getting to psychology here. But we also are finding that respondents in these large-scale surveys are at basically kind of failing, conventionally failing grade levels when it comes to answering other basic questions. Now, these basic questions are important ones to ask. I think it's important to know that antibiotics, what antibiotics do, and that they kill viruses or they kill bacteria. That they're very important. These are very important things to know. But it's also important that people understand the scientific process too. And I think that these types of questions don't necessarily get at process-related approaches to understanding science. And in psychology, since we're not a part of mainstream discussion in scientific literacy, we kind of have to do our own thing as far as assessing psychological scientific literacy goes. But you look at some of the questions that we might ask in contrast to the ones that you see here, and what might psychologists ask in a true or false format? Brain damage is always permanent. People with schizophrenia do not have multiple personalities. Money causes people to feel happier. Experimental methods are required to establish cause-effect relationships, and most people regard homosexuality to be a mental disorder. I think the ability to answer these in true-false format is a pretty important one, and we can probably argue that society in general would benefit greatly from knowing how to answer these and other important questions for our discipline. And not to say that knowing whether or not the center of the Earth is hot isn't important, but I think if you look at this list here, you can make an argument that, yeah, knowing that the answers to these questions is an important one in terms of being an individual being a scientifically literate citizen. And so since psychology is hardly represented in standard measures of scientific literacy, for now we use other means, kind of our own homegrown means for measuring scientific literacy of psychology. And in my work, and I know in the work of others, we found that examining people's beliefs in common psychological myths is a great place to find out about people's base level knowledge about psychology. And I think this quote from philosopher of science, Sir Karl Popper, sums it up well. Science must begin with myths and with the criticism of myths. And so I want to discuss, actually for a lot of the talk, I want to devote it to discussing the relevance of common myths about behavior and how they relate to scientific literacy. I think that bringing up the topic of myths is a great opportunity to bring up the importance of skepticism, critical thinking, and hypothesis testing. And I think that one resource, actually, a recent book by Lilienfeld and others, 50 Great Myths of Popular Psychology, is an excellent resource. And my colleagues and I actually have done some work looking at students' beliefs in common myths, in particular in general psychology students, a good place to start. And in a recent study, we surveyed 103 general psychology students. These were mostly freshmen and sophomores. And about half of them had taken a psychology class before, like in high school, and maybe a couple of them had had a college psychology course before. But most of them were pretty new to the field to the study of psychology. And we sampled students from both a public and a private liberal arts school. And we had 24 questions we asked about myths. And we rather than have these students rate them as true or false, we had them identify whether they strongly disagreed, agreed, or strongly agreed as the response options to these myths. And the phrasing of the questions was done as they're conventionally put. For example, we only use 10% of our brain, opposites attract, and so on. And so the students read through these questions, and they rated the degree to which they believed that they were true or false. And we also included some control questions in the questionnaire in which statements that were not of myth variety were asked. And in fact, in the first slide, I want to go through and just show you what was found in this survey. In the first question we asked, as you can see here, one way we learn is by responding to the rewarding and punishing consequences of our actions. Okay, so that's a pretty common observation and not of mythical proportions for sure. And we see that most of the students agreed with this statement. And actually in the graphs that I show, this is how the majority of them will come through. You'll see at the top, strongly disagree, the second one, disagree, agree, and strongly agree at the bottom. As you can see, most students are agreeing with those statements. Another question we asked, exposure to chronic psychological stress can compromise the body's immune system. And we got overwhelming agreement with that statement. Our experiences of flavor come from a combination of taste and smell cues. And the majority of students, without any background in psychology, are able to agree or strongly agree with that statement. Very nice. Drug addiction is accompanied by changes in brain chemistry and functioning. We got strong agreement with that one. And it is possible to be good at remembering some types of information, but poor at remembering others. And here we got strong agreement there. So that was very, very promising. Now, these last five statements do not constitute myths by any stretch, and they allow us to contrast truthful and, one might argue, kind of obvious observations about human behavior with myths. But let's start out with the granddaddy of all myths in this next one and see how students responded to this one. Most people only use 10% of their brain. Well, everyone's heard that one before. Is it true? Of course it's not. But you do find that a lot of people do believe that. And our respondents, over half actually did disagree with it, which is good. But you find still that a lot of students do agree with that, and it makes sense because they've heard that a lot and they haven't heard much else about the brain other than that. And so you do find a lot of students agreeing with that before they've taken the general psychology course. This one here, people can be categorized as either left-brained or right-brained. We find that about half and half agree versus disagree with that statement. So about 50% of students are agreeing with that characterization of how the brain's organized. Subliminal messages can be used to persuade people to purchase products. And we see here that over 80% of the students agree that they can be used to persuade people to purchase products. Our dreams often have a deep symbolic meaning. We find that over half of the respondents agreed with that statement. Psychological traits such as personality and intelligence and disorders such as depression and Alzheimer's disease can each be traced to a single gene. The majority of the respondents did disagree with that, which was encouraging, although we did have a high proportion. About 40% agreed that you could trace complex disorders and traits to a single individual gene. We can learn new information such as new language while asleep, for example, listening to CDs while asleep with headphones on. And most of the students did disagree with those, although you do see about just under 40% agreed that you could do that. Most adults experience a midlife crisis in their 40s and early 50s. We find that the majority of the students agreed with that statement. Extrasensory perception is a well-established scientific phenomenon, often a very fun topic to start out a general psychology course with ESP, integrating it into research methods and things like that. And it probably needs to be the case that we continue to talk about it and integrate it because a lot of students do agree that it's a well-established scientific phenomenon, close to half of them in this particular sample. Students learn best when teaching styles are matched to their learning styles, and this is one of the ones where we found the strongest results on the agree side. Over 90%, almost all the respondents agree that they learn best when the teaching styles are matched to their learning styles, for example, being a visual versus an auditory versus a kinesthetic learner. People commonly repress or block out memories for traumatic events. We have overwhelming agreement with that statement, that people commonly repress memories for traumatic events. Our handwriting, graphology, our handwriting reveals clues about our personality traits. Most of the students, a very high number of them, agreed with that statement. Venting your anger will lead you back to a more positive mood or outlook, the catharsis hypothesis. Most of the students, about 70% of the students agreed that catharsis is going to lead you back to a more positive mood or outlook or reduce anger. The CSI phenomenon, psychological profiling, is a valuable and effective tool for solving crimes. Most of the students agreed with that one, over 80% of them. Vaccines such as the MMR vaccine, measles, mumps, rubella, can cause autism. I was actually quite pleased with this one. This has been in the news a lot lately. People have heard it, and I was quite pleased to find that the majority of the students were disagreeing with this statement, so kudos. Men and women communicate in completely different ways. In other words, men are from Mars, women are from Venus. And most of the students agreed with that statement, that in other words, men are from Mars and women are from Venus. Again, the repetition of something like that can lead to the belief in it. Most people with mental illness are violent. I was pleased with this result because most of the students disagreed with it, so good there. ECT, electroconvulsive shock therapy, is a very dangerous procedure. And in this one, similar to the learning styles, we found a lot of people agreeing with this one. About 3/4 of the respondents agreed that ECT was a very dangerous procedure. Opposites attract. We are most romantically attracted to people who differ from us. And here we see about an equal division. About half the students agreed with that statement. People with schizophrenia have multiple personalities. And this is one we always deal with. And yeah, about half the students did agree that schizophrenia was the same thing as having multiple personalities. So there's a lot of information that comes from a survey like this, I think. It's rich with information and very helpful, I think, to those of us who teach any psychology class, but probably especially the general psychology class. And one thing I want to emphasize is that I'm not trying to make it sound like students are foolish for believing these things, because certainly freshmen and sophomores are not alone in their beliefs here. I mean, a lot of people believe these things. And there are reasons why. I mean, for one, you just hear many of these things being repeated over and over. And I think that, that there's a lot of value, though, in looking at data like this. And again, remember why we're doing this is because we don't really have a common metric for assessing scientific literacy in psychology like the NSF tests do. And so myths are a good place to do something like this. It's kind of a starting point. And I think that the myth-busting has its role in teaching. There are definite advantages to it. I want to just explore these for a moment here. The pros, the examples that we give are typically familiar to many students. They'll have an opinion on them generally. You got to kind of sometimes tease it out of them, but they have an opinion on it. The examples can be very engaging and entertaining, but they also do contain some pretty serious subject matter. And they're also a great starting point for further analysis. And that's an important thing, is once you've established, you've told a student, okay, you use more than 10% of your brain, it's really only effective if they're told why that's not true, and that's kind of reinforced. And by the way, at the bottom of the screen there, I have a reference to the Blessings, who have done a lot of work in myth-busting. They have this program called Psychbusters, some resources for using myth-busting in the classroom, and wanted to give some kudos to them for what they've contributed. Some of the cons to using this myth-busting approach. For one, you can run the risk, if not done carefully, of alienating or insulting the beliefs and intelligence of others. And some major issues in psychology may not be completely amenable to a true false level consensus. The midlife crisis one, or the opposites attract idea. We can say that on average, people are more likely to gravitate towards somebody that's like them, but there are exceptions to that. There are people who are also find people who are unusual or exotic relative to them to be attractive, and so there are the exceptions to it, not like the exceptions you see to gravity, for example. And so there are some cons to the myth-busting approach, but I think those I guess the lack that you can't answer them in true-false form also gives you the opportunity to explore some of the contours and the nuances of psychological research. Also, if they're not properly implemented, if this myth-busting strategy is not properly implemented, it can bringing up myths can actually reinforce the erroneous belief. The students might actually become more prone to believing the myth if you just bring it up and don't follow up with it. And the authors here of this particular article, I thought, did a very important study here where they looked at how best to correct for student misconceptions about psychological myths. And what they found is that, in a nutshell, what they found is that if you combine a lecture and also you have textbook coverage that disabuses the students of the myth, you find that they're much less likely to believe it in the end. But it seems to be that they need to have some repetition to read it and also hear it in lecture to get past the believing in the myth. And one thing, knowing whether these myths are true or not is not necessarily a complete metric of scientific literacy of psychology. As we learned previously, scientific literacy is many things. It also includes the ability to think about, evaluate, and apply scientific information. And I think in order to do that, beyond just looking at whether a myth is true or false, we need to look at scientific literacy maybe in a little more complex fashion where we can kind of model the process and then fit student learning into this model. And so this is something I use actually in my own teaching quite a bit in development of assignments and exams and papers and things like that, where at the top there you have knowledge gathering, and that's basically just getting the terms and concepts defined and making basic observations about the phenomenon you want to understand. And then moving over to the right of that and below, scientific explanation, that's where the research methods part comes in, where you need to establish there's a basic understanding of what a scientific study would entail, randomly assigning, sampling, establishing cause and effect if it's an experiment, knowing how to look at and interpret correlations at least a basic level. And so the scientific explanation is what helps organize the knowledge that's been gathered. And then I think a very important piece of this is critical thinking, which sometimes critical thinking and scientific thinking are equated with one another, but there's also some sort of meta-processing in critical thinking that separates it from scientific explanation, because critical thinking, I think, is more about the ability to evaluate claims and sources, and the ability to also to question the claims of others as well as one's own thinking and reasoning, the ability to question that too, and that's an important part of this. And also with the application, seeing how the information applies to the individual and the society. So let's actually return to the point made at the beginning of the talk. How would someone with scientific literacy interpret this story compared to someone who lacks scientific literacy? It wouldn't suffice just to ask somebody a true or false question whether or not people do silly things at office parties. We might need to take something like this and model it based on what I just showed you in this model of scientific literacy. So how would this look with knowledge gathering, for example, with regard to this study about misbehavior at office party, drunken misbehavior? Well, one bit of information or bit of knowledge you want to know is what alcohol does. One of the things it does is lower inhibitions. Also, in a knowledge gathering phase of teaching, you'd probably talk about how the body becomes conditioned to drug-related cues and to context. Classical conditioning is going to be relevant here. It involves acquiring a conditioned response to the alcohol with repeated pairings of the CS, or the context, in that case the office party, or not the office party, with the US, which is the alcohol. So just getting a basic understanding of what the terms and concepts that are required to make sense of something like that. Now, moving over to scientific explanation, we would establish here scientifically that tolerance to alcohol develops with repeated administration. And in this particular study, what's relevant here is the body is responding less to alcohol over time because it's becomes conditioned to the cues, like bars or being at home, that are present when it's normally consumed. And so this causes alcohol's, one of its psychological effects, which is disinhibition, to be reduced over time. However, when it's consumed in that new environment, such as the office party, those conditioned responses don't occur, and that's what leads to that greater release from inhibition compared to when somebody uses alcohol in a familiar environment. The gist of that is in the article, but without some kind of basic understanding of classical conditioning, not just what a conditioned stimulus is, but what it means, is required to kind of get through and understand what the basis is for a finding like that. In the critical thinking part of things, you might, with that particular study, you might ask, does this effect occur in settings other than workplaces or university settings? What other psychological processes might account for why people embarrass themselves at office parties or similar situations that might not just be attributable to classical conditioning? And then also there's the application side of things. I think that once you've gone through this, read through the study and thought about it critically, these kind of pop out. We think, well, probably would want to inform employees and employers about the risks. At the very least, somebody could embarrass themselves with a lampshade on their head. At very worst, though, people could experience, a sexual assault and things like that. That's brought up in the article. So there are consequences for this. And it also can generalize to other situations where risky behaviors can occur, such as drunk driving. And one question is, does this apply to the same phenomenon apply to other drugs, such as heroin or cocaine? And it turns out that it does. And so the true-false myth-busting type approach is really good in terms of promoting scientific literacy, but also we find that when you model it in a little more complex way, you can really pull out a lot more information and encourage students to think in this way. So I see that I've just got a couple minutes left, so I want to wrap up with some conclusions here. I think that myth-busting can be a very effective starting point for promoting scientific literacy of psychology, though considering some of the pros but also the cons of doing so and being careful about how it's implemented. Getting to that scientific literacy model, I think a process-oriented approach to teaching psychology can move students towards higher levels of understanding and knowing about science, how to do it, how it applies, thinking critically about it, getting them also excited about it. And I think that those media studies are a great way to go about that. And also the hub science of psychology belongs in the measurement and discussion of scientific literacy. What does I mean by hub science? Well, in psychology, as it turns out, you could call it a hub science. These researchers here had actually used the social science citation index to examine relationships amongst thousands of peer-reviewed publications. And notice psychology in large font and bold print. And the reason that's the case is because using this method of looking at citation indexes, you find that psychology is a hub science, meaning that it pulls or integrates together a broad array of work across these disciplines that you can see are most adjacent to it. And so in terms of its importance to science, you can see that it's up there with some of the heavy hitters in scientific and engineering fields. So obviously, I wouldn't, preaching to the choir here that we all think that psychology is important, but that graphic certainly does demonstrate it, I think, in a very convincingly. And so the final point I want to make is, why is psychology relevant to evaluating and conceptualizing scientific literacy? And this gets at not just in promoting scientific literacy to our students and basing our assignments and things like that, based on using scientific literacy concepts, but moving it into the broader goal of getting our field into the discussion of assessing scientific literacy more broadly, nationwide, and things like that. And why is it relevant to evaluating our scientific literacy? Why is our field relevant? First of all, our field, of course, is empirical, basically. We focus on method and process, definitely. Experimental methods and different ways that information is acquired. There's a strong focus on that. And psychologists certainly, if anybody does, have a heightened awareness and understanding of cognitive biases and pitfalls that can lead to non-scientific thinking. I think critical thinking is something that we're highly aware of, and that's a good thing in terms of what we can contribute to scientific literacy. And I finally like to acknowledge those who helped, Daniel Kortz and also Erin Richmond for help with the survey administration, and thanks very much to Annette Dean for her wonderful illustrations. Thank you very much.
How can you start incorporating this research into your courses? And so we'd like to now turn it over to Master Teacher Bethany Fleck for our interactive Q&A. Dr. Fleck is currently an assistant professor at Metropolitan State College of Denver, teaching a wide variety of psychology courses there. Her research is focused on early childhood education, studying memory and social development in the classroom, as well as an active line of work on college teaching pedagogy, including ways to understand and successfully incorporate technology into teaching. So to get started, I have a question from an instructor. And the question is, what are some ways that you can incorporate social media, such as Twitter, Facebook, YouTube, to help teach scientific literacy to undergraduate psychology students?
I think that's a great question because of the popularity of social media, especially among our students. I think that one of the best parts of social media is that it can be very relevant and very recent. So we can post relevant news clips or topics or articles to something like a Facebook page and have our students have immediate access to that. Facebook is, for example, a place that they spend a lot of time there, so they're already there. So if we can meet them there with some of this psychology information, I think that that can be helpful. This really relates to what Dr. Krause was saying, where he showed the example of the popular press article and was able to work the scientific model using that, that popular press article. So I think if we can do that through the use of Facebook or even Twitter, we're going to really engage students and take it a step further from just, reading that article at face value to actually breaking it down based on scientific literacy. There's really so much out there on the internet, and it requires our students to be very smart consumers of information, to not take things at face value and to break it down. And if we can use something like Facebook to help us get access to those articles, to start a discussion, I think that that could be a really good tool.
Okay, great, thanks. And we have another instructor question. This one being, how do you use something like myth-busting in the classroom without making students feel embarrassed or alienated?
Yeah, that's a great question. I think that sometimes our students can feel a little bit embarrassed when they answer, that they strongly disagree or strongly agree with a myth when that, in fact, is not true. One of the most important things to start with is your overall classroom climate. I think that's a real important foundation there. I actually have a classroom climate section of my syllabus where I talk about how important it is for us to be able to ask questions, to take risks, to know that it's okay to be wrong when you're learning new information. And so I think right from the beginning of your semester, it would be important to set that classroom climate. Some other ways that you could avoid alienation or embarrassment would be to have students talk with each other about myths. A lot of times they're more comfortable admitting those things to one another and kind of having a laugh over it than they would be if you had cold called them in class or had them raise their hands based on their beliefs. So a lot of times when it's a subject that I think my students might feel a little bit embarrassed about, I'll go ahead and let them talk to each other first. I find that to be really helpful. The other way that I would go ahead and try to make them feel comfortable or less embarrassed is to talk about my own misconceptions. I teach child development classes and education classes, and I talk about all of the wrong things I've done when I'm taking care of children and the things that I've messed up on. And sometimes you can have a really good laugh when you think about those, and it helps them to open up, especially seeing that the instructor or the teacher has also believed these things or misbehaved in some way. So making fun of your own misunderstandings, I think, can be a helpful tool.
Great, thanks. And we have a comment, too, I guess, which is the flip side of this. One instructor says that I think students can sometimes feel empowered when we bust myths. They begin to recognize the value of their education and how exciting it is to learn. So it's a great way to look at it, too.
Yeah, I think that's a fantastic comment. That's very true. it's really great as teachers when we can see our students get really excited about something that they've learned. And these myths are things that so many people believe in, that I find that when we bust those myths, they go ahead and talk to their fellow students, and they bring it home and they talk about it across the dinner table. And that can be a really powerful thing. I think the comment's absolutely correct.
So our next question, again from an instructor, is critical thinking and application are the higher level categories in Bloom's taxonomy. So how do you get your students to think at these higher levels?
Sure. So Bloom's taxonomy can be helpful for us as instructors when we're setting up goals and thinking about, the level that we would like our students to be thinking. So it begins with knowledge and understanding, and those would be some of the lower levels. And then, as you said, the higher levels include things like critical thinking, application, and synthesis of new information. And it can be really difficult for us to get our students to be thinking at those levels. What I think is important is to start at the bottom. So we are starting off with the knowledge, we're starting off with the understanding. And once we have them really competent there, then we can start to move up to the higher order thinking skills. In a lot of cases, our students haven't been required to apply or analyze or even synthesize. They haven't yet had to do that. And so we need to be really explicit in our requirements of them. So we need to tell them exactly what we expect them to do, and then give them ways that we can, achieve that goal. So I think that being explicit and saying, okay, I'm expecting you to be able to apply this, and what does that application look like? What does that actually mean? Is going to help them. The other thing that I think would be really important in getting our students to the higher level thought processes is to scaffold them. So scaffolding is a very Vygotskian idea, where at first we provide them with a lot of help, a lot of structure. One of the ways that I do this is through their flashcards. So students like to make flashcards. At least mine have liked to make flashcards in the past. And they have an exam, they'll make their flashcards, and then they don't do so well on the exam, and they come to me and they say, look how much I've studied. And we sit down and we look at the flashcards together, and I try to scaffold their flashcard making. So we look at them and I see, okay, well, here you have a term, and on the opposite side of the flashcard you have the definition. And I say very explicitly to them, this helps you know the material. You're at the knowledge part. You're at the very beginning of the taxonomy. And then I say, the whole exam was application. It was critical thinking. You needed to compare and contrast theorists, and you needed to apply it to new situations. I said, will this flashcard help you? And I see this little light bulb go off in my students where they say, no, it won't. It'll help me along the way, but it won't get me to the end point. And so we sit down and we write out flashcards that will hit each of the levels of Bloom's taxonomy for each concept. And I do this with them. Usually it's for their second exam because the first one didn't go so well. And then we'll do it again for the next exam. Then on the final exam, I expect them to come to me with those flashcards already made. So it's a scaffolded experience, because at first the guidance is really strong. And as they start to understand what's expected of them and how to accomplish that goal, I pull away and require them to do more and more of that type of thinking on their own. So I think providing structure and help is really important, and being very explicit in the fact that these are the types of skills that we're looking for from our students now.
Great. So I have one question. How would you say or explain to a student how scientific literacy compares to critical thinking?
Sure. And Dr. Krause mentioned this in his talk. A lot of times our students and people will just assume that critical thinking is the only skill that's required in scientific literacy. And I think to explain it to our students, we could pull up the model itself that Dr. Krause presented. So the model has the critical thinking as part of it. But there's so much more that's involved in scientific literacy. The application is involved, just gathering information about what we know, understanding why or how we know something. And so I would just sit down with them and discuss the model, or discuss the model with their class. And say, yeah, critical thinking is definitely a big part, but it's not the only piece.
All right, great. And one more instructor question for you. This is, so many tests of scientific literacy are of the true false variety, yet so much of psychology does not necessarily fit this format. So given this, how do you get students to understand that psychology is a science?
Sure. Yeah, scientific literacy in the field of psychology is a little bit different than in some of the other domains. In some of the other areas, like demonstrated in the talk, there are simple true or false, right or wrong type of answers. In psychology, we have a lot of gray area. We have a lot of research studies that come back and say, you know, we can conclude this, but, you know, and there's some kind of explanation there. So you don't have as much completely right or completely wrong. And, you know, I don't think that this takes away students' perception that psychology is a science. I think that instead we can use that ambiguity to further teach skills, such as developing and supporting a hypothesis or interpreting data. We can develop our critical thinking skills of results or other people's conclusions. I think as long as we're taking them through the scientific method each time we look at research, it doesn't really matter if the end result is definitive, like a true-false answer. We're still really accomplishing the goal of systematically studying human behavior and following that scientific method.
Okay, and I've got a suggestion to share, actually. This suggestion from an instructor. And it's a suggestion on a way to encourage students to share their different perspectives or beliefs. Is this professor uses a collection of articles from Taking Sides, which examines a topic like, is television viewing responsible for the rise in childhood obesity? And this reading includes 2 position statements expressing both sides of the argument. And prior to discussing each topic in class, she has her students write about their own position based on their readings in their Blackboard discussion. And then she requires the students to reply to 2 other students' posts in the Blackboard discussion group, which is a great suggestion.
Yeah, I think the Taking Sides is a great tool. I've used it in some of my classes as well. And I like the idea of having them do that prior to coming to class on Blackboard to really get the discussion going before they come into class.
Great. Well, this actually brings us to the end of the Current Directions in Psychological Science speaker series. And so on behalf of Pearson and APS, I'd like to thank our speakers for volunteering their time to share their current research and insightful teaching strategies. And I'd really like to thank all of the students and instructors for participating and helping to make this 2-day webinar such a success.